Hello folks, welcome to the materials world. As you can see this question number 15, the potential energy U of R is basically interatomic distance. So U of R of a pair of atoms is placed at a distance R in a solid is given by this expression U of R is equal to minus A by R to the power cube plus B by R to the power 7. So it is basically asking the equilibrium distance between the atomic pair, that is R naught. So of course it can also ask the energy at equilibrium distance, that is bond energy, U naught also. So it's very important to understand how potential energy is changing with the variation between space between two atoms, how this attractive energy part and repulsive energy part is contributing to the equilibrium energy, that is bond energy. So we are going to understand it using plot. So before I jump to the main concept, let me tell you honestly that I should apologize for not being punctual. I am not uploading videos since last 3 to 4 weeks. The reason behind it is basically the huge burden of coursework which is online going on in IIT Bombay. And another reason is there is already 3 gate batches which is going on right now. So to maintaining all the study materials, to satisfying them, explaining everything simultaneously, giving the exams and the coursework for IIT Bombay, it was so difficult for uploading videos. So I thought that let me upload this very important concept. This concept is basically you cannot find anywhere, solution you cannot find anywhere in any book. Basically the plots will be given in book, but they are not going to explain everything. So it's very important to upload. So I will try to upload at least 10 minutes videos or a concept every week or every 2 weeks. And so let me tell you one thing, 3 batches is already going on. And many students are coming just after 1 day, 2 days, after every 3 days, 4 days. Students are coming and saying that I was not aware about your coaching class or online class, so that is why I am joining late. So can I join? So I thought that let me upload a video and telling them that yeah, classes is going on and if you can join, and if you can't afford the online classes, you can join at least our Telegram group or WhatsApp group. Link is there inside the description. In the description, please check it now. There in the Telegram we can clear the doubts also. They can ask any doubt and will provide all the test series. Okay, so I'll inform them, all the students, that we are going to give the test series. Being connected with Telegram will be very beneficial to you. So if you want to join classes, you can join, and if you want to, if you can't afford the classes, so then you can join the Telegram group also. So basically that was the announcement. Now let me jump to the concept. So to understand the bonding between two atoms and the force acting between two atoms, to understand them, let me introduce you. If the two atoms are kept at infinite distance, okay, and they are bringing closer to each other, so how many forces can be there or can exist, and how their forces are changing with the interatomic distance r. So initially they are at infinite distance and now they are bringing closer, okay, at distance r. So the forces between them are changing with r. So how they are changing, that is important. So why we are bringing these two atoms from the infinite distance? Because initially we are assuming that these both atoms are isolated. It means that there is no extra any other force acting on this atom. The same situation is for this atom also. There is no any other extra force from any other atom. So they are isolated initially. Now they are brought closer to each other, so that we are going to study what are the forces which are acting between them and how those forces are changing with r. Ultimately, when the net force will be 0, these two atoms will be in equilibrium, and that situation is known as bonding. Okay, so when these two atoms is going to be so closer that their net forces is going to be 0, at this position when F net is going to be 0, the whole system is in equilibrium because net force is 0. and this equilibrium condition is going to give you the bonding, I mean the bonding situation, and the distance between them is going to give you the bond length, that is R naught, okay, where F net is 0. So this bond length is asked in that question, in GATE 2019 question. So let me introduce you the forces which are acting between these two atoms. You all know that atom is made of nucleus that is positively charged due to proton, and neutron is neutral, and the surrounding with the nucleus there is three-dimensional electron cloud, okay, and these electrons are negatively charged, we all know. Now another atom is having nucleus and it is positively charged simply, and the electrons are three-dimensional 3D clouds surrounding with it, so they are negatively charged. Now if the two electron cloud is going to interact, if both two atoms are brought so closer to each other, that is we have already known that the same charge repel each other, so electron repulsion is going to occur. Now here the positive charge, I mean nucleus is also going to repel. There is a repulsion force. What if this positive nucleus is going to interact with electron cloud? So positive and negative is going to attract each other. I mean there is attraction also. There is another scenario where this nucleus is going to attract with this electron. So basically there is also attraction. So basically we have two type of forces acting between them. One is repulsion and one is attraction. So these forces, how these forces are acting with R, that is important. And the point where F net, suppose repulsive force is Fr and attractive force is Fa. If the net force, I mean Fa and the net force means algebraic sum, that is Fa plus Fr, that is net force. If the point where Fa plus Fr is 0, or that is called F net force, Fn is going to be 0, that point is known as equilibrium, and the energy between them at that point, at that moment of time, is called as the energy is called as bond energy, and this situation is a bonding situation. So basically we have Fa and Fr, and F net is the algebraic sum of both of them, that is Fa plus Fr. Now we all know that the work which is done to bring them closer is going to be the energy between them. So if the net force is F net, and the distance or the distance to which they are brought together is, let's say, dr, so F into dr is going to give you the dw, or the work done, force into displacement. And if you integrate on both sides, we are going to get total work done, or that is called energy, can be equal to the F net or dr. So F net is, we have just seen, F net is what? F net is Fa plus Fr, algebraic sum of both of them. Now what will be the initially they are at the infinite distance, and they are brought closer to each other at r distance, so infinite to r. Okay, now of course integration of dw initial to final position will be just total work done, that is called net energy. And because net force is working on. Now F net can be written as Fa plus Fr. So Fa plus Fr into dr is going to be what? Is going to be your net work done. Now Fa is what? Fa, now this can be manipulated, this equation can be manipulated. So Fa dr can be written and Fr dr can be written. Just leave the same unit, I mean same limit, infinite to r and infinite to r. Now Fa into dr is going to give you the attractive part of energy, that is Ea, and Fr dr is just work done, force into displacement, but is r, so repulsive part of energy, that is r. So basically the net energy is going to be Ea plus Er. So in net energy, or this is function of r actually, sometimes it is also denoted by U or U of r, that is also energy. So it is an algebraic sum of both attractive part and repulsive part. Now let's interpret this the same logic in the graph. So in the graph, as you can see that this is force versus interatomic separation. Now when the r is very large, so attractive force is not dominating, I mean attractive force is changing slowly. Why? because attractive force is very lower. Why it is lesser? So because attractive force Fa works on the principle of Coulomb's law, 1/4 pi epsilon naught q1 q2 by r square. So here you can see that if r is very large, then Fa will be very small, because they are inversely proportional. Okay, so here when r is very large, the Fa is so small. Now when we decrease the r, the Fa is increasing simultaneously. When you decrease r, Fa is going to increase. It keeps increasing when you decrease r. Now if you see that, what about repulsive force? That this dotted is going to be represent the repulsive force. Okay, so if you initially when you decrease the r, there is no net change in repulsive forces, but when they are so close, you can see that r is just this one only. Okay, initially it was so long r, now it becomes so small. So when r is so small, when you can see that here from this point, this dotted is repulsive part. So you can see that when the atoms are so closer, the repulsive force comes into play. Okay, the role comes here only when they are so close. So repulsive force drastically, rapidly increases. Repulsion part rapidly increases. Its slope is so high, and here attractive force is slowly increases. Now if you combine these two curve, we are going to have the net curve or net force. The net force is going to be initially when r is large, initially attractive part is dominating. Basically when repulsive force comes into play, the role, it bends. Okay, so it goes to negative, because the dominating force is repulsive now, so it will go down. Initially it will follow attractive path, and since from this radius the repulsive force is dominating, so it bends and it goes into negative force, I mean downward. Okay, so you can see that here when this is net force, when net force is going to become 0, that point is known as equilibrium point, because net force is going to be 0, body is in equilibrium, system is in equilibrium. So this point, this dotted is showing, I mean this distance is showing equilibrium distance between two atoms, that is bond length between two atoms. Okay, now basically it is A and R. So AR Rahman, whatever you can understand, you can memorize them using this. Now here mirror image will be the energy variation with R. So initially when attractive force is dominating, so of course attractive energy will dominate. This is attractive energy part, this is attractive energy part, and this is repulsive energy part. So it is just the mirror image of force portion. So here when attractive force was dominating, of course attractive energy will dominate initially when you decrease R. Now at a smaller r, the repulsive force is going to dominate. So of course at some distance, at very near to equilibrium distance, the repulsive force, also repulsive energy is going to dominate here. This is attractive energy comes from the attractive force, and this is repulsive energy comes due to repulsive force. So if you can combine, initially attractive energy is dominating, then repulsive energy is dominating, so it will go up. So what is equilibrium position here? So everybody wants to be in their minimum energy state. That is what we know as from the thermodynamics, right? So the minimum energy is going to be the equilibrium condition. So this is going to be the equilibrium condition. So this is going to be the equilibrium distance R naught, and of course this is energy. So basically this is going to be the E naught or bond energy. So if you superimpose these two graphs, so how they will looks like, let me show you. If you superimpose the both graph, you are going to have something like this. Force is going to change something like this, and the energy is going to be something like this. So energy is going to be something like Energy is going to be something like this. So as you can see that when this is force, net force, and of course this will be force, and this plot is something like energy, that is E of R or U of R, both is correct. And here you can see that when the F net is going to be 0, the body will be in equilibrium, the system will be in equilibrium, and when at that point when F net is going to be 0, energy will be minimum. Energy will be minimum, and that minimum condition is known as equilibrium condition. Okay, so basically this distance is going to be, since this is R, so this distance is going to be the equilibrium distance R naught, and this distance of course it will be same when F net is 0. Now since it is just variation of energy, this axis, so this distance is going to be E naught, that is bond energy, or energy between two atoms when they are at equilibrium. Okay, so energy E or U of R will be equal to U naught, or E of R will be equal to E naught. Energy becomes E naught, or simply R will be equal to R naught. R will be equal to R naught when and only when F net is 0 and U of R is minimum. U of R is minimum or F net is 0. When U of R is minimum, R becomes R naught, or R is the value of R at that point is equilibrium distance. This is the point which can be utilized to solve that GATE 2019 question, and it is very important because R naught is already asked in the GATE exam, so it's very high chance that they can ask U naught. Okay, so if when U of R or E of R is minimum, you can see that at this point it is minimum, so the R at this point is going to be equal to R naught, so R becomes R naught. So I mean, if I have given you one equation, U of R is equal to, let's say I have to write both attractive part and the repulsive part, so let's write attractive here it is attractive A.R. Rahman, so he is a attractive and a repulsive force, then it will be mirror image of that repulsive energy, and below in this I mean fourth quadrant it will be attractive energy, means this shows attractive energy and this part shows repulsive energy. So basically attractive energy part is negative, so minus A by, let's say, R to the power m plus, this is the expression actually, okay, where n is always greater than m. This is the actual I mean this is the equation which shows the variation of U with R. Okay, where R has some power and n has some power. M has some value and n is some constant, and A and B is constant, and R is just the interatomic space or interatomic distance, and n will always be greater than m. You can say that when you increase the R, U is going to be decreased. Okay, see, when you increase R, U is going to be decreased as it is decreasing. This length is U, right? This length is U. It is going to decrease. Okay, now I'm going to tell you. So now you understood that in here this function is when this function is going to be minimum, when U of R is going to be minimum. What does that mean? R will be equal to R naught from this concept. Okay, because here U of R is minimum, so R becomes R naught here at this point when it is a minimum. Okay, so we can apply minima condition here to find out R naught. Minima. What is the condition of minima? What is the condition of minima? Minima condition is the first differential of function with variable R is equal to 0. That is the condition of minima. So basically, to find out R is equal to R naught, simply what you are going to do since at R is equal to R naught, the function becomes minimum. So we can apply this minima condition. Just differentiate one time and put equal to 0. You are going to get R is equal to R naught. Understood? So basically, when r will be r naught, if u r becomes minimum, so u is minimum means we can apply condition for minima. Condition for minima. So let me remove everything. So u of r is minimum at that point. U of r is minimum at that point. R becomes r naught. So we have to find out this only, right? So basically, the equilibrium distance r naught. So the condition for minima is what? Minima or maxima is what? In both case, du or minima or maxima, we just put du by dr. First differential equals to 0. The plus 2 concept which you might have learned. Okay. Now, if you put du by dr is equal to 0, you are going to get r is equal to r naught. The moment when du by dr becomes 0, it means u of r becomes minimum or maximum, whatever. R becomes r naught or equilibrium distance. That concept you are going to apply there. Okay. Now, once you find out r is equal to r naught, you can put r is equal to r naught in the expression u of r, and you are going to get the answer of u naught. When you put r is equal to r naught, when you put r is equal to r naught, u of r becomes u naught. Okay. So let's solve that numerical. Let's solve that numerical which is asked in the in GATE 2019. Okay. Then I'll see. So simply what you have to remember is, at r is equal to r naught, function becomes minimum. At r is equal to r naught, see, you can see u of r becomes minimum. So we can apply condition for minima, du by dr is equal to 0, and that point from this expression we can get r equal to r naught. That is what you are going to understand. That's it. Okay. So I am going to solve that. So let's solve a simple example. Let's solve before going to solve that GATE question. Okay. Suppose u of r is given minus a by r plus b by r square. Let's say a is equal to given 1 and b is given 2. Okay. So minus 1 by r plus of course b is 2, so 2 by r square, u of r. Okay. Now I have told you r becomes r naught when u of r is minimum, right? The condition, remember the graph. Okay. So basically you have to just put du by dr is equal to 0 and r will become r naught. So du by dr will be 0. Before doing that, let me write this in a simpler way so that you can differentiate. U of r will be minus r to the power minus 1 plus 2 r to the power minus 2. This power 1 will go in numerator and it will become minus 1, and this power 2 will go in numerator and it will become minus 2. Now you can differentiate now. Du by dr will be what? It will be minus 1 will come, so it will become positive and it will become r minus 1 minus 1. And minus 2 will, you can differentiate it, it will become minus 4 and r to the power minus 2 minus 1. So basically what we are going to see, 1 by r square and minus 4 by r to the power 3. And I have already told, put du by dr is equal to 0, then r will become r naught, right? So put du by dr is equal to 0. So 1 by r square minus 4 by r cube, that is du by dr equal to 0. Now the moment when you put du by dr is equal to 0, at that point when du by dr is 0, it means that is the condition for minima. It means r becomes r naught. So you can put here r naught. So simply what you are going to see, it will become 1 by r naught square will be equal to 4 by r naught per cube. Now r naught square can be cancelled out. It will be 1 by r naught will be simply it will become 1 equal to 4 by r naught, because r square will be cancelled out. So basically r naught is going to be 1 by 4. It depends what is the unit of a and b. If the unit of a is typically in meter, then nanometer, then r naught will be in nanometer only. If a and b are angstrom, of course I will tell you how to find out the unit of a and b. So right now just see, if a and b are given in angstrom, then r naught will be in angstrom. Okay, let me give you another example, then we'll go to solve that question. So suppose u of r is given. Oh, I forget to tell you how to find out u naught. You understood what is how to find out r naught. Now let me undo. Okay, now here once you got r naught is equal to 1 by 4, you can put this value in u of r equation. So once you put r is equal to r naught, u will become u naught. Yes or no? So you can just put r is equal to r naught here and you are going to get your u naught. So it will be just minus 1 by, here I am going to put here, but it is simplified one by putting a and b. So 1 by r naught is how much? 1 by 4, and plus 2 by r naught is 1 by 4 the whole square, and you are going to get u naught. Okay, let me give you another example. Suppose u of r is given as minus a by, of course the function will be always this only, r to the power m plus b by r to the power n. Now in the question m is given as, let's say, 2 and n is given as 3. Always remember, n will always be greater than m. I mean I mean the portion, the negative portion will be what? Negative portion will be, this is repulsive and this is attractive. So negative portion is going to be always attractive force. So this is attractive part, attractive energy, okay, and this is the repulsive part. So basically you can see that n should be always greater. Why? Because if n is greater, means power of repulsive part is greater, it means this is going to be dominate when r becomes so small. Okay, so power is different, high, that is why it is going to dominate when r is smaller. You can see that if r is 1, so r, let's say r square, let's compare with r square and r cube. So r square will become 1 and r cube become 1 only. Okay, now if r becomes smaller, let's say 0.01, now if you solve r square, it is going to be 0.0, 20 is there, so it will become 4. Okay, and RQ is going to be what? 0.0000001, yeah. So you can see that how dominating this is. At greater r, let's say r is equal to 1, r square and RQ is same. But when we decrease r, I mean initially there is no, initially when r was so greater, there is no repulsive part, I mean attractive repulsive part. When we comes, only attractive part is there, there is no repulsive part. When we decrease r so lesser, you can see repulsive part is dominating. Why? Because when r is smaller, RQ or r to the power n is going to dominate, repulsive part is going to dominate. Okay, that is why n will always be greater than m. Now suppose I am giving you another question, minus a, minus showing the attractive, okay, a by r to the power suppose m plus b by r to the power n. Now I am going to give you a is, let's say joule, a is given as, let's say 1 joule meter to the power minus 2, meter to the power 2, okay, and b is given as 2 joule nanometer to the power 3, okay, and m is given as 2 and n is given as 3, let's say. Okay, now if you put here, this is given, so if you put here u of r becomes minus a is given as 1 by r to the power m r square plus b is given as 2, so 2 by r to the power 3. Okay, now you can differentiate it. You want to find out r is r naught, right? You want to find out r naught, calculation of r naught. So I have already told you when r will be r naught, when u will be minimum, the graph. Okay, so minimum, how can you find out? Put du by dr is equal to 0. So du by dr will be what? You could differentiate it honestly, this portion, it will be minus r to the power minus 2. If you differentiate it, it will become 2 r to the power minus 2 minus 1, so 2 r to the power minus 3, or 2 by r cube. Okay, so I can write here 2 by r cube. Now if you differentiate this one, so 2 by r cube can be written as 2 r to the power minus 3. If you differentiate nx x to the power minus 1, so n minus 1, so minus 3 into 2 minus 6, r to the power minus 3 minus 1, so basically it will minus 1. So basically what you are going to see, 2 r to the power minus 3, if you differentiate it, it will become minus 6 r to the power minus 4, so minus 6 by r to the power 4. So I can write here minus 6 by r to the power 4. Okay, now we put, I have already told you, differentiate with respect to r and put equal to 0, then r will become r naught. Okay, now you can find out r naught also, right? So how can you find out? Just factorize it and solve it, that's it. It's so simple. Okay, so how can you do that? So here take common, so 1 by r naught to the power q can be taken common, 2 by r naught, just 1, sorry, everything is already taken common, so nothing will left in denominator. So if you take r naught to the power q common, so it will become 2 minus 6 by here it will become r naught only, because 3 is already gone, so it's equal to 0. So 2 minus 6 to the power r naught will become 0. So basically 6 by r naught will be 2 only, it means r naught will be 6 by 2. So basically R naught will be 3. Is it correct? Let me check. 2 minus 6 by R, so it will go that. So of course 6 by R naught will be 2. Yes, it is correct. Now R naught will be 3 nanometer. Why? Because A is given in nanometer. Okay, now you put R naught is equal to 3 here, and you are going to get your U naught. So what will be U naught? What will be U naught? Sorry, undo. What will be U naught? So U naught is going to be put here. So U of R is how much? Minus 1 by R square plus 2 by R cube. Now put R is equal to R naught. You are going to get U naught. So 1 by minus 1 by R is how much? 3. So 3 square plus 2 by 3 cube. So you are going to get 1 by 9 plus 2 by 27. So basically you are going to U naught. U naught will be always negative. Let me tell you why. Why U naught is negative? Why U naught is negative? Because plot itself you can see. You can see this is U naught, right? This is U naught when R naught is minimum. This is R naught and this is U naught. So you can see that the U naught is going to be minimum only because it is negative side. Okay, now I hope you understood. Now how to find out unit of A and B? In GATE it is not asked, and it is high chance that it can be asked. Okay, last year when I taught my student, they don't in 2018 they thought that it is not going to ask, and it was asked in 2019. So in 2021 it is very chance that they can ask unit also. Okay, if they touch a question from bonding. It's very important topic. That is why I am making this. Okay, so 2 marks can be easily secured. Now how can you find out A unit of A and B? Okay, so suppose U of R is given as minus A by R to the power M and plus B by R to the power N. Let's say M and N is also given. So minus A, let's say it is not given. First it is given. Okay, let's simplify it. R square plus B by R to the power cube. Now U of R. Now you see that this is energy part, right? This is attractive. This is attractive part. Okay, so it is energy. So whole value, I mean the whole unit should give in energy like joule, and this whole expression should give energy only because it is repulsive part, joule. And if you add joule plus joule, you are going to get U, that is in joule. Okay, electron volt, whatever. I am just taking. So this expression should give joule only. It means A minus A by R square should give only joule. Now R is in nanometer, or let's say meter or whatever. So since R is in meter, so M square. Now minus here, what you are going to put so that you will get only joule. So of course you are going to put meter square, so that meter square is going to be cancelled, and the remaining part what you are going to put. Since we need joule, so I am going to put here joule only. Right? You understood? You understood? So basically the unit of A should be what? Joule meter square. Let me repeat it again. Okay. Now suppose this should give joule and this should give joule. So joule plus joule will give you joule only. That is energy. So B by RQ should give joule. Okay. Now R is nanometer. That is length. We already know it, right? So R, that is nanometer. So nanometer cube. So here B should be watt, so that we get only joule. So B should be, of course here it should be nanometer cube, so that this nanometer is going to be cancelled, and other than this nanometer we need what? We need what? At the place of B we need what? Joule, so that this nanometer will be cancelled out and we will get only joule. So you understood what is unit of B? Unit of B will be joule nanometer to Q. So Q is coming from this part, right? And this part has a power 3, and actually this has part of M. Actually minus A R to the power M means A should have unit joule nanometer to the power M by R is suppose nanometer, so nanometer to the power M. So nanometer to the power N can be cancelled out with nanometer to the power N, and we are going to get only joule. That is the whole part. Okay, so basically unit of A is what? Joule nanometer to the power whatever the power here. It is 2, then it will be 2. If it is 3, it will be 3. Now I hope you understood. If you don't understand, please remind my video and see again. Okay, you will understood. I know. Okay. Now this is the way we can find out the unit. So what is unit? Let me summarize it. So unit of A will be, if the power is minus R to the power M, then unit of A will be joule nanometer to the power M. If R is in nanometer, it should be angstrom also. It can be anything. If plus B by R to the power N, if power is N, so unit of B will be joule nanometer to the power N. If it is angstrom, then angstrom to the power N. I hope you understand it. Okay, let's solve that question. Okay, the gate question. Okay, so here it is the gate question, I mean 2019 question. So you can see u of r is given. Okay, and you can see that a and b has already given, a is also given and b is also given, and by seeing the unit you can see that r should be in nanometer, right? And the 3 power is saying that m should be 3, and this b 7 power is saying that this power should be 7. That is what I just explained, right? So everything is perfectly given, no unit problem, no unit conversion, nothing is complicated. Just what you have to do, it is asking what equilibrium distance, I mean r naught. So what I have already just taught you, put du by dr is equal to 0. That's it. And first of all put a and b, because it should be number, and just take it, just differentiate and solve it. You are going to get r naught is simply you are going to get r naught. Okay, so I'm not going to differentiate it, or should I differentiate? I don't think so, because you have understood the concept. Just what you have to do, put du by dr is equal to 0. Okay, and if you are going to put du by dr is equal to 0, so differentiate this, you are going to get. Okay, so what we are going to get, let's do it. Okay, I don't want to put okay, let's make it. Okay, so minus a r to the power minus 3 plus b r to the power minus 7, that is u of r. Okay, du by dr will be what? This minus 3 minus 1, it will be 3a r to the power minus 4 and plus minus 7b r to the power minus 8. Okay, put is equal to 0. Now you can take r minus 4 common. So r to the power minus 4 can be taken common. So it will become 3a and minus 7b, and r to the power minus 4 is already outside. So it will become only 4 is equal to 0. Now this can never be equal to 0. Why? Because r is not 0. So basically this is going to be 0. So 3a minus 7b r to the power minus 4 is going to be 0. And don't forget, when you put 0, r become r naught, right? R become r naught. Yes or no? So it will become r naught only. So basically 7b r naught to the power minus 4 is going to be 3a. So r naught to the power minus 4 is going to be 3a by 7b. So basically r naught is going to be minus 4. If it will go that side, it will become 3a by 7b whole divided by minus 1 by 4. Minus 4 will go that side, so it will become minus 1 by 4. 4 will be 1 by 4, x will be 1 by x. Okay, now you know already value of a, you know already value of b, put here and take the power of minus 1 by 4, you are going to get the r naught. So that will be your answer, because since a is already in nanometer, so you are going to get the answer in nanometer only. If you put r naught is here, you are going to get u naught. Okay, so I hope everything is simple and fine, nothing is complicated, and you understood how to find out. You understood how to find out a, you understood how to find out b. You understood how to find out unit of A and how to find out unit of B. You also understood how to find out equilibrium distance, and why we are putting du by dr is equal to 0, because energy is minimum at r is equal to r naught. I have already explained in plot. Okay, now you understood how to find out u naught also. So you understood the most important part in atomic bonding. If they will ask a question, they will certainly ask from this part. Okay, other than just 1 mark question. If the 2 marks question is going to be asked, it will be asking from this topic only, because this is the topic where has some numerical ability. Otherwise other topic in bonding has no ability. It is just I mean MCQs. Okay, so I hope you understood everything. Now don't forget to join our telegram group. Okay, there I will share. I can if you have any doubt, you can ask there also. If it is of course I will clear your doubt. And if you will be connected with me, definitely you will be benefited. Okay, and if you want to join our online classes also, you can join, because there you will get personalized guidance. Okay, personally I will guide you, I will explain each and everything. Okay, and so you can join our WhatsApp group also. Link is in description. Thank you.